Absolutely. So, to kind of set the stage, uh, let's just look for a minute at what the ML processes does compared to what we were used to. When big data didn't come in, we were, as I explained earlier, we could look at the data, work with the data, and you kind of supervised learning is kind of the new term, but that's what we did. We built models that were supervised by us and enabled by us, working with the production team. You kind of threw it over to the IT tech folks, and they would recode it and say, hey, now we can put it into our pipeline, right?
Mhm.
And then you would go back and forth saying, hey, it doesn't look like what I expected it to look, so on and so forth. So when big data
Mhm.
came, it kind of opened the eyes of everybody. You were always constrained with little data, and you had to try to think about ways of sampling it. But when big data came, the options opened up. So I don't have to limit myself. There's so many other things that can be happening, the patterns that I may not have observed, and I can build more solid models, more accurate, more robust models against the bigger samples if I chose to, or go against the raw data if I had to. So now the question became, how do I handle it? And which is why the evolution of machine learning processes and algorithms came into being. So it was kind of merging the probabilistic aspect of building models and looking for patterns and building predictions with the efficiencies and the computational advantages of the machine. So when the two came together, this was really great for doing and handling big data because it removed the challenge of me spending 3 months going through
Mm.
iterations of the model.
Right.
So now you had this algorithm that could run through 1,000 iterations against your data set and identify the features which are most important, which are which inform you more about the hypothesis that you've set up for the model to, run against. And in that process, you can basically see your months kind of reduced to seconds.